Yes, hi guys. Now let me continue from for integration of transcendental functions. Now in case of transcendental functions, we are taking now trigonometric functions. Okay, first trigonometric functions, then I'll take other functions as well. Okay, which are known algebraic functions. We are discussing about integration of trigonometric functions. Alright, which are known as transcendental functions. Now let me take the next topic. In lecture number 35 now, the series starts. Now in this case, we will take the integration of multiple angles. What are the multiple angles? If there are some positive integral powers of sine, cosine, etc., and they are multiplied, they are independently, there are powers of sine and cosine. Okay, even powers of sine and cosine in this case. Now, if those powers are given to us, and if we multiply sine powers and cos powers, okay, with to each other, and then multiply them, and then a series of sign will be obtained, and after that it will be transformed into the multiple angles of either sine or cosine. After that we can integrate them with the help of that. We know that sine of nx equal to how much? Integration of sine x, integration of cos nx, and here for example, now I'll explain this. But what is integration of cos nx? That will be equal to sin nx upon n. Similarly, what is integration of sin nx? N means multiple angle, n times the angle x. So what is integration of sin nx? That will be minus cos nx upon n. So in this way, finally we will integrate the given functions. So first of all, if the sine powers of sine is given, powers of cos is given independently, then we have to convert them into the help of trigonometric series, or trigonometric formulae, into multiple angles of sine or cosine. Okay. After that, we can integrate them. So now they are integral functions. And secondly, if there is multiplication of sine overs and cosine overs, okay, sine and cosine overs, and after that, after multiplying them, we will get combination of multiple angles of sine or cosine, and after that, integrate them. This by the formula which are given. So today I'm talking about the integral of multiple angles. So integral of today the topic is this is lecture 35. Now in this series of lectures, in this series of lectures, I have to talk about. Let me talk about. Okay, the topic is to integrate or integral of is the integral of right, the integral of multiple of angles. Okay, multiple of angles today. If there is as I told you, that if there is multiplication of, or let me, if powers of sine or cosine are given, and either they are independently given, independent, or in multiplication, or in multiplication, or in multiplication. If in multiplication, okay, if in multiplication, they can be, okay, transformed into, transformed into a multiple of angles by trigonometric formula. They can be transformed into a multiple of angles, of sine or cosine with the help of trigonometric formulae. The help of trigonometric formulae. Trigonometric formulae. Okay, and we know that what is integration of, and finally they can be integrated. They can be integrated by the following formula, by the following method. Number one, if there is integration of sine of nx into dx, okay, we know that what is multiple of angles is given, n times multiple of x if it's given. Then what is integration of this is nothing but cos of nx, because integration of sin x is negative cos x. It is cos nx upon n. Okay, this will be integration, and integration of cos of nx into dx is equal to sine of nx upon n. These formulae will be used finally. Now let me take the questions one by one. Okay, let me take the simple question this and this, and after that I'll take multiplication of both ends. Okay, let me take the simple question, either the third question first or the fourth question, or let me take multiple of those two questions. No problem, let me take from the beginning. That's not a problem. These two formulae will be used. So now let us take the questions given there, or given here, which are taken from students' queries in the class and online study. Mostly online queries students have given me a number of questions of this kind. I have collected these questions from student queries online or in the class studies. I always make a diary of all the questions and then I just remove the problems of the students. So this is for just benefit of those students. Now let me take these questions one by one based on this concept of this. And let me further clarify that what does it mean. Okay, so for that let me take the illustration of questions from beginning. Okay, now let me take questions from the beginning. For example, here it is given. We are given here sine square x and cos 4x. Okay. Now, question number, let me take one here. Now this is sine of integration, sine square x into cos 4x into dx. Now first let me take that what is sine square x, cos square x in terms of complex numbers. Okay, so let this we know about. Let x here. Okay, let me take sine x plus. Okay, what I'm talking here. This is, let me take cos x plus I sine x. This is complex number which we have discussed about. Equal to z here. This is z or g. Okay, this is g here. And this is from complex numbers are taught in complex numbers and removers theorem, etc. There we discussed about these complex numbers. Okay, and cos of x minus I sine x. Okay, this is imaginary number. Imaginary, and this is real part of this complex number. And this is equal to z raised power minus 1. That means z 1 upon z here. But we write z raised power minus 1. That is better. Is g or z? That means what? If I add these two, this is first one, this is second one. On addition, we get here adding these two. Let me write here adding, or on addition we get. Let me take on addition. On addition, we get, what do we get here? If we add these two, this will be twice cos of x. Okay, and this cancel out, and it will be z plus z raised power minus 1. This is, let me take third equation. And on subtraction, on subtraction of second from first, we get, what do we get here? By subtract here, this will be minus sign, this will be plus sign, cancelled out, and these two are added. So this will be twice I. Okay, or this implies that twice I into sine x equal to z minus 1, because this will be minus sign here. Okay, on subtraction, if I subtract second from first, then this will be minus sign, this will be plus sign, this will be minus sign, z minus z is for minus 1 equal to twice sine I, this ix. This is take fourth one. Okay, so what do we know about? Now from De Moivre's theorem, also from De Moivre's theorem, De Moivre's theorem, also from De Moivre's theorem, we have, if I write here 2 sine nx, let me take 2i sine nx or sine n times x, if it is equal, it will be z raised power n minus z raised power minus n, if it is n times multiples. Okay, so this will be there, and cos raised power this value, and 2 cos of nx equal to z raised power n plus z raised power minus n. This is your, let me take second equation. This is fifth one, I'm sorry. This is the fifth one. And this is the sixth one. Okay, so this value means this angle will come out. This, if it is n times multiple of angle, it will give us this value. Okay, so that is what we have obtained here. The cos nx, if it is there, then z nx is there. Okay, let me check what I'm writing here. Yeah, so this is what we have obtained here. Z raised power n. So this is by De Moivre's theorem we have obtained. Okay, this I was just checking my diary that if I'm going to the same direction what I'm going to prove here. Just after that we can solve these questions. So what is this? This formula here, 2 cos nx equal to z raised power n plus z raised power minus n. Okay, this is the formula here. That means if any this kind of situation comes out, we will directly convert that into either this, if it is minus sign in between, z raised power n minus z raised power minus n, then it will be equal to twice I sine of nx. Alright, and this will be z raised power n plus z raised power minus n, if it is there, will be 2 cos of nx. This value 2I sine nx, for this is just nothing. 2 cos x equal to z plus only one times, it is 1 into x. Okay, if it is n time, it will be 2 into cos nx. If it is sine, this one I sine nx, sine n here, then powers will come here. This is by De Moivre's theorem. We have explained in De Moivre's theorem. I've discussed that in detail. Okay, in differential calculus. So please see my lectures in differential calculus on De Moivre's theorem, complex numbers and De Moivre's theorem. There I have discussed this over. Now, this situation will arise, and then we will write in place of these kind of powers, power equations, these values 2I sin nx and 2I cos nx. Power, suppose this is 5, z is equal to 5 minus z is equal to minus 5. It will be 2I sin 5x. It will be, suppose 5 powers are there here also, it will be 2 cos 5x. In this way, we will use these formulae there. Okay, let me take now the question given here. But the question here, so question given to us is, what the question given to us, let me check. Okay, so now here we have cos square ns. Cos square ns here. Okay, so if I write here cos square nx and cos 4x here. Okay, so let me Now we know that 2i into sine 2i into sine x whole square, if I write here 2i sine x whole square. Okay, because we have to find out the square of sine square x finally. Then first we have to express this, and also cos 4x I talk about. Okay, and similarly 2 into cos x whole 4. This also we have to calculate. And after that we will multiply them, and finally what is the solution that we will calculate. So this value will be then calculated. So in this here, if I write it sine x and multiply 2i sine x, that is nothing but z minus z is for minus 1 whole square. Okay, and this is nothing but z plus z is for minus 1 whole 4. So these two are there. Now let me multiply them. Therefore 2i into sine x whole square into 2 cos x whole 4 is equal to these two values, z minus 1 whole square into z plus z is equal to minus 1 whole 4. Now these first let me calculate, and after that finally let me express the left. So what it will be? It will be 2i whole power 2 into sine square x into 2 raised to power 4 into cos 4x. Okay, this will be I'll solve this. Let me first express this implies that this is equal to this, or this will be 2 that I square is minus 1, because we know that I square, which is I square equal to minus 1, because in case of minus 1 and in case of non-real numbers we write minus 1 equal to I square. So I square or I square here is I square is equal to minus 1. So in place of this will be the first one 2i square, that means 2 square into I square is minus 1, so it will be negative sign, and 2 raised to power 2 and 2 raised to power 4 will be 2 raised to power 6, 2 raised to power 6 into sine square x into cos 4x. Okay, that means sine square x into cos 4x is we have to find out. Finally we will see here that what is this, therefore sine square x into cos 4x is equal to minus sine, say 1.64, because 2 into 2 into 2 6 times, because 3 times it is 8, 2 into 2 into 2, again 2 into 2 into 2 into 2, I mean 3 times, sorry, so that will be 8 again, so 8 into 8 is 64, finally this is minus 64, okay, minus 60, sorry 1.64, this minus 64 I have to take to this side, it will be minus 1.64, and these two values are there, z into z minus, sorry, z minus 1, z minus 1 whole square into z plus z minus 1 whole 4. Now this we have to solve. Finally sine square x into cos 4x, integration of this whole will be integration of this whole. So let me finally solve it. This is whole equal to, let me write it. So what is here? Let me take. Therefore now we have calculated, we have reached up to this. Therefore sine of integration, or let me first take sine square x into cos 4x, sorry, this is 4x only I'm talking. After that I'll substitute the integral sign, sorry, integral sign finally I will put, but let me first find out what is sine square x and cos 4x. So this will be minus 1.64. Let me solve this equation. So this will be now z minus z, sorry, z minus z raised to power minus 1 whole square, and if I okay, divide this into two parts, what is this, z plus z minus 1 whole square into z plus z minus 1 whole square in two parts. It will be z minus z minus 1 whole square into z plus z minus 1 whole square into z plus z minus 1 whole square. If I write in this way, this will be minus 1.64. To these two, if I multiply, this is a plus b into a minus, sorry, a plus b into a minus b. That is z square into b minus z minus 2 whole square, because they have the same powers, whole square into z plus z minus 1 whole square. Now let me solve it. So finally we obtain here. Okay, now let me multiply this. First open this. We 1 from 64. Let me solve this equation. This will be whole square of this will be what? We z4 plus z minus 4 and minus 2, 2 only. It will be minus 2 only. Into this, if I open it, will be z square plus z to the power minus 2. Yeah, plus 2 only. Now let me multiply this whole. Finally we get the z value. Let me first solve it, multiplying them these two. For the final solution in this. Okay, so this will be minus 164, which I am keeping as it is. Now let me sorry, multiply by z4 these three. Okay, first z4 into z square, that will be z6. z4 into z minus 2, that will be plus sine z is for 4 minus 2, that means plus 2. z4 into 2, it will be 2 into z is for 4. Now by z minus 4, this will be plus z is for minus 2, because minus 4 plus 2, if I add them, that will be minus 2 only. Alright. Then z minus 4 into this, it will be plus sine z is power minus 4 and minus 2 added will be minus 6. Okay. Now by minus 2, sorry, z minus 4 into 2, it will be plus 2 times z into z is power minus 4. z4 into 2, 2 into z is power minus. Now by minus 2, we will get minus 2 into z square, this one, plus 2 into minus 2, sorry, it will also be minus 2, but all the 3 will be negative, because by we multiply with minus 2 here. Minus 2 z square I have written, this will be minus 2 z is for minus 2, then minus and minus, this is 4, 2 to the 4 here. Okay, now let me collect all the like terms here. So what are the like terms here? Let me put them in brackets. Now z6, z6 here. What is z minus 6? This is z minus 6 plus z minus 6 here. I have to put that in one bracket. Now let me talk about z4. Is 2 z4 twice z minus 4, here only 2. If I take 2 common, it will be z4 plus z minus 4, similar value. Now let me talk about z minus 2 or z plus 2. Now here we have, okay, z this minus 2 2z plus z minus 2. Okay, so is and then plus z square, and this is minus 2z square. This is plus z minus 2 and minus 2. It will be negative sign only. But only one times negative value. Negative value, because this is twice z square minus, and this is plus z square. And minus z square will be there. And out of this, z is for minus 2 and minus z is for minus 2 will be negative value, only z minus 2. So minus sign, if I take common, will be z2 plus z is for minus 2. Only these two, this one, and this single. Okay, so this minus 2 z square and z square, this minus z square, minus sign I have taken common, and this will also be negative, because minus 2 z is for minus 2, and this is, sorry, this plus z minus 2, it will be minus z minus 2. That is minus sign I have taken positive plus sign. Now, next thing, what is the numerical value? We have obtained only minus 4. Okay, so this is minus 4 here. Let me take minus 4 here. Okay, now let me substitute the value. Now we know that what is z raised power n plus z raised power minus n. That was, this is positive value plus sign. Twice cos 6x. Okay, so let me write here. Minus 1.64 will 2 times twice, this is 2 into cos 6x. 6 angle is 6 times, because if it is n power n, we n into x. I gave from the De Moivre's theorem, we know about this. If it is z is power n plus z is power minus n, and 2 into cos nx, Now in this case is 6x, so 2 into cos 6x plus this is 2 already. This will be 2 times again 2 into cos 4x. This value minus sign, this is also 2 into cos 2x because angle is twice, and this is minus 4 only. Now I can take 2 common, got 2 and 2 can be taken common. It will be nothing but minus 1.32 in bracket cos of 6x. This is plus 2 into cos of 4x. This is minus cos 2x only because 2 has been removed. I have taken common and minus 2 only. This is minus 2 here. Now integration sign can be put. Therefore, let me write here. Therefore, let me now remove this. Therefore, this whole value. Therefore, sine of integration of this into dx is equal to, let me substitute here only integration sign. It will be minus 1.32 sine of integration. The first step. Now minus 1.32 will be with all. It will be cos of 6x, first one into dx. Let me separate them. Plus sine 2 into sine of integration. This is cos of 4x into dx. Minus sine, it is sine of integration, cos of 2x into dx, and minus 2 into sine of integration into dx. So this is 2 into only 1, that means only dx. Integration sign I have put. This is the value which we are going to find out. Therefore, integration of this whole, these two will be this much. Finally, we have obtained this value. Now let me talk about the integration of this whole. So what the integration of these? Now we can integrate them because they are converted into multiple of angles. Okay, this was the logic which I wanted to express. Okay, in the beginning, the introduction of this topic or beginning of this lecture, I just talked about that how the multiplication of sines and cosines, and they are converted into by series of trigonometric series. I mean formula of multiple of angles. Okay, they are called formula trigonometric formula. We will convert them into multiple of angles, and then they are integral functions. Now they are integral. Now let me integrate them. So this is minus 132. This will be first integration is sine 6x upon 6 plus 2 into sine 4x upon 4. Integration of cos is cos 4x is sine 4x upon 4 minus this will be sine 2x upon 2. Okay, this will be minus 2 into x only, because integration of 1 into dx is only x. Okay, this is this constant of integration we can write here. This is the answer. Finally, let me write it in this way. Sine component 32. Okay, and this will be 1.6 in sine 6x. This is plus 1.2 here, but 2 to 4. 1.2 sine 4x. This is 1.2 sine 2x minus twice x plus constant c here. This is the answer. Sorry, constant c I can write away from. So this will be up to this plus constant c plus constant c. This is the answer here. Question number first we have done. Okay, this is the process of integration of these functions. The most we have to think about z to the power n plus z to the power minus n equal to twice cos of nx, and if it is z n minus z to the power minus n, this will be 2i into sin nx. That denominator we have to use here, and then complex numbers, value of complex number, we know about z n, z to the power minus 1 equal to 2 into cos x, and z minus z to the power minus 1 equal to 2i into sin x. Okay, then remove we use. So this is question number 1, which has been expressed here. Now let me talk about second question. Now second question is of what kind? Let me talk about. Okay. Now question number second. Okay. Now question number second is one trigonometric function, that is sine of 6 as into dx. Okay. Now sine 6x we have to plot this. So we know that 2i, since let me write 2i into sine x whole power 6. So we have to find out sine x power 6x. This will be what? 2i sine x is z minus z minus 1 whole power 6. This is the value. Okay, now let me open this one. Now we have to open this by binomial theorem. What is binomial theorem? We have already expressed in the previous lecture. So what is binomial theorem? So with the help of binomial theorem, we have to express this value. Okay, so this bracket we have to open with the help of binomial theorem. So what is the binomial theorem? This is z is over 6 minus sine. This will be z 6 into z is over 5, one power lesser than this, and then this will start with z is over minus 1. Now plus sign, because this is negative sign in between, so alternate negative positive will be. Second step will be third step will be 6 into 5 upon factorial, that means 15. Also like that the formula that n into n minus 1, that means 6 into 5 divided by 1 into 2, this is multiplication, into z is power 4 now, z minus 2. This will increase and this will, the power will be minus 2, minus 3, minus 4 like this, and this will be lesser 6, 5, 4, 3, etc. Okay, so this is the value of next will be negative. This will be 6 into 5 into 4 from factorial 1 to 3. 3 factorial 1 into 2 into 3 means 3 factorial. Okay, this is z is power 3, z is power minus 3. Next step will be, let me write here plus sign, 6 into 5 into 4 into 3 upon factorial 4, that means 1 into 2 into 3 into 4 into z is power 2 into here z is square into z is power minus 4. Okay. Till z is power minus 6 comes out, the final value. Up to that we have to express this. Next will be negative sign, will be factorial. Here 6, 5, 4, 3, 2. And in the denominator we will have factorial 5. It will be 6 into 5 into 4 into 3 into 2 on factorial 5. That means 1 into 2 into 3 into 4 into 5 into z only. Power has decreased. Now z is power minus into z is power minus 5. And final will be plus sign, z is power minus 6 only. Why? Next, this will be factorial 6. For 6 into 5 into 4 into 3 into 2 into 1, that is factorial 6. The denominator also we will have factorial 6, so 6 upon factorial 6 upon factorial.